This is fairly related to the capabilities in Java for using the functional API. However, you can use some of these ideas in other languages as well. The functions may be different, the syntax and the way that you access may be different. The concepts can be applied in a lot of other languages as well. So with that said, let's talk a little bit about a few basic operations we can perform, and then we will kind of take it up notch and look at a few different solutions available. We'll look at a few problems along the way and see what the power of this is. This is something you can use from mostly from Java 8 onwards. There are a few functions that probably are available only in more recent versions of Java, but they are fairly minimum in the number, so you can benefit from even older versions of Java at this point from Java 8. So let's talk about some functional APIs, and then we'll talk about what are some of the operations we can perform on the data itself. Well, the very first thing, of course, is operation on a collection of data. So we can perform a filter operation. So just as an example in here, suppose I have some numbers given to us, and let's say we have a list of numbers 1 to 10 that I want to work with. So given these numbers, I want to be able to do a filter operation. So what does it mean to do a filter? So when you have a collection of data, whether the data is defined already or it's a stream of data you are getting, data you're reading from a database, doesn't really matter where the data is coming from, but you want to work with those data. So for example, in this case, you can say numbers start for each, and you can print those numbers out right here like so. So this is going to print all the numbers in that particular collection. But I don't want to print all the numbers. So what I might actually want to do is to use a stream on it, and I can do a filter, and I can say given a number, I can do a number, let's say mod 2 is equal to 0. So this is going to give me only the even numbers in the collection and not give me the numbers that are not even. So that's a filtering operation. So a filter operation, think of a filter like a gate at a garage. It might open to let a car in, but closes and the next car cannot go through, and it may open again and let another car in. So for every single value that comes through, it either opens up and let it flow through or rejects it, and you cannot really use that. So you cannot really pass that. So that could be an operation of filter. So here's a way to think about it when it comes to filter. A filter takes a predicate. So it takes a predicate as an argument, where the predicate may return a true or a false, and that's basically what a filter is going to take as an argument. And what you can do is you can say that 0 is less than or equal to number of elements is less than or equal to number of elements in the output is less than or equal to, you can say, number of elements in the input. So essentially what that really means is the filter is going to either throw all the objects out, all the values out, you will not get anything in the output. Here's a way to think about it. If I ask you, raise your hand if you are older than 300 years of age. I'm hoping there is nobody, except for one person in the room, nobody is 300. In fact, he's walking by right now, right? So nobody else is 300 years or older, right? Well, that's a 0. There's nobody that old, I'm hoping. But if I ask you to raise your hand if you're older than an hour, I'm hoping everybody will raise the hand. Well, that's either 0 or all. But if I ask you to raise your hand if you're older than, let's say 30 years of age, some of us may raise the hands, some of us may not raise the hand. So it's between 0 and the number of elements. But what you know is the elements in the output are a subset of elements in the input. If I take a collection of people in this room, and if I say, I'm going to give some gifts to people who are, wearing a red color shirt, you don't want suddenly somebody who is not in the room suddenly rush in and say, hey, I've got a red shirt, I want a gift. Sorry, you're not qualified. You cannot have a member in the output that's already not a member in the input. So that's a subset that you're going to be dealing with. So that's basically what a filter is doing. Map, on the other hand, is actually an operation of transformation. So you can say a map function, if you have a collection of data, x1, let's say x2, all the way up to xn, you can say that if you have a function f of xi, the result of that is going to be y1, y2, and all the way up to yn. So essentially, it's going to say that yi is equal to a transformation of f of xi. So the map operation is going to operate on every single element in the collection and perform a transformation. What can we tell about the map function? Map takes a function, and if you really want to do, you can put a uppercase f on this function as the argument. So essentially, what you pass to the map is a function. But what you also know is the following, that the number of elements in the output is exactly equal to the number of elements in the input. You're not going to get any new elements, any new number of elements in the output. However, the data and the type of the, you could say, type of the elements in the output, you can say, may be different, than you could say the data and the type of the elements in the input. So there is no correlation directly in terms of the map itself with the input and the output. For example, if you take the people in this room, the input is a collection of people. But if I say I want to know what your date of birth is, well, your input is a collection of people, but the output is a collection of date of birth. But how many date of birth should I see in the output? It should be exactly as many number of people in the room. That's basically the transformation. So in this case, what you're going to be dealing with is, if you have a stream of type t, and you perform a map of a function which takes a t as an input and a result as an output, then the output result of this is a stream of type, in this case, R. So that's basically what determines the type of the transformation of the data. So let's take a look at an example of this. If I go back to this code and say .map, and given a number at this point, I want to return a number, let's say, times 2.0, you can see that the output is a stream of double values. So what do we have here? This is a stream of integer that is coming in, but that's a stream of double that is going out. So that's a transformation of data that happened. And why is that? Because we gave it a function that takes an integer and returns a double. That's what we pass to this particular map function. And as a result, it's a transformation of stream of integer to a stream of double. So that's basically what you are doing here, is the transformation of data. The cardinality is guaranteed to be the same, but the type and the value of the output could be different. So we talked about the filter, we talked about the map, but then comes the operation of reduce. So what in the world is a reduce operation? Let's think about this with a little example to understand what reduce may actually be doing. And for this, let's take a little bit of an exercise, if you will. Now, I mentioned that given a collection of people, I can ask for, let's say, everybody's age. So what's that going to be? So if I have a collection of person, let's say P1, P2, P3, P4, and I have all these people that are in the room, let's say, how many other people we have. But what I want is everyone's age in this room. So I could say A1, A2, A3, and all that could be the age of the people who are in this room. So for as many people in the room, I have as many ages in here. But assume that I want to find the total of the age in this room. I want to see the collective age. If we all were, taking the age and total it, we can then say, oh, this room contains maybe 400 years of experience in this room, or whatever it is, right? Maybe it's 400 years, maybe it's 1,000 years, who knows? But how are we going to compute that? So here is a way to think about it. What we can do is think about this as immutability for a minute. So imagine that I give you a little post-it note. But imagine this is a write-only post-it note. You can write on this post-it note once, but if it's written on it already, you cannot scratch it and rewrite on it, right? So now I take the post-it note, and on a post-it note, I put a 0 on it, and I give it to him. So what does he do? He takes a post-it note, he says, oh, it says 0, and he looks like a 25 something. So what does he say? He says 0 plus 25 is 25. He tears off the post-it note, puts it away, takes a new one, puts a 25 on it, right? And passes the 25 to the person next to him. So what does he do? He receives a 25 on a post-it note. He looks like about a 27 something. And he says, oh, 25 plus 27. And he writes on a new post-it note a 52 and passes it down to the next person, right? And then what does he do? He looks like about a 30 something, but he wants to tell everybody that he's 20. So he adds the 52 to a 20 and then passes the new post-it note down the line. Now you can imagine one post-it note going to a person, a new post-it note emerging, and then another post-it note emerging. Are you visualizing that in your mind? And then it's right there on the 5th row right now, right? And it keeps going and going and going. And at the very end, the last person, what would they have? That last person in the room will have a total of everybody's age in the room minus 10, isn't it? That's because of him, right? So essentially, that would be the total. Now, if you're able to visualize that moving through the room, now let's write that into code. So what are we going to do here? We are saying, hey, take that result, let's do a reduce, and what's the post-it note I gave you? Do you remember? A 0, that's correct. Good, you're paying attention, right? And we gave a 0. And what does he do? He says the partial total, comma, my age, and what does he return? Partial total plus my age, right? So that's basically what you're going to see up here, is that it's going to return a plus my age is what it's going to return as a response from that particular call. So now we can say, total, of age of all, the cool people in this room, right? So you can say that's I'm not recommending you write such a long variable name, but you get the point about what it's going to return, isn't it? So that's going to be the value it's going to return in this particular case. Now in here, of course, I'm going to simply take this as a 2.0 just as an example, and we can run through that in this particular code. So this says, I'm going to do a map, I'm going to do a reduce, I'm going to take this value that's being given to me, I'm going to perform the total plus a my age. Oh, let's fix this right here, and I'm going to return that particular value back to the caller. In this case, the result was a 60. So how did this actually work? The way this works is, you have an element 1 and an element 2 and an element 3 and so on, and the reduce function starts with the initial value that is being given to it, right? So you take this initial value and you provide that value. So then it says, I'm going to take the initial value that's given to me, and I'm going to perform that operation that you want to perform, take the result and send it across, and the next one is going to perform the operation, take the result and send it across, perform the operation, send it across, and it's going to work with each of these values that you provide. So essentially what this is going to do is, it takes the initial value, sends it to an operation, and takes the output of that, and in the meantime though, it's going to take an element that is being given to it, that is going to be the element EI that's coming in, and it takes that element as an input, and in this case, it's going to take the output that is coming from this and feed that right back in here like so. It's going to bring this back in here as a value, and that's going to flow through as a feedback right there. So and you can imagine that now, right? So a person receives the data that comes on the left side, takes their own value, performs the operation, pushes the output. The output now becomes an input to the next person's operation. So that's the feedback that keeps going on as you move from one person to the other. So this is why this is a reduce operation. And what we did was we took everybody in this room and we reduced it down to the total age of the person, total age of everybody in this room. So if you're able to visualize that journey, that little post-it note goes through the room, now you can think about how the reduce operation actually works. Now, another way to think about it is different language authors like to call this differently. The concept in functional programming is called reduce. But imagine that you are in a gym and you are working out. Maybe you decide to do a plank. So you're on the floor, but you don't want to be on the floor, so you have a nice floor mat. And on the floor mat, you are laying down, you are doing your workout. And when you're done, what are you going to do? You're not going to just leave the floor mat there and walk away, right? That's not very polite. So you then, after your workout, you take your floor mat and you start rolling it. And you make a cylinder out of it, right? And then you put it in the corner. If somebody says, what are you doing? You're saying, I'm folding the floor mat. Well, so in some languages, they don't call it reduce, they call it fold. So a fold, of course, you can ask the question, are you folding from the left to right, or are you folding from right to left? So there's a fold left operation, there's a fold right operation. Depending on what you're doing, addition is no problem, but what if you're subtracting it or doing some other operation which is not symmetric, then the result of fold left and fold right may not be the same. So in the question there is, do you start your operation in the beginning of the room and go this way, or do you start the operation at the end of the room and come this way? And again, for totaling, it doesn't make a difference, but what if we are doing some other operation which is not symmetric? The result may be different whether we go from front to the back of the room or back to the front of the room. So those are the things that are going to be different. So a reduce operation is just like the fold operation, and you are taking a collection of data and then reducing it to a single value, right? That's what you're doing with the fold, with the reduce. So that gives you an idea how this code is working. So in this case, the output of this operation simply become the input, the first input of this operation on the next call, and this becomes the value that flows in from the top function, and that's basically how we keep moving forward in terms of the reduce operation. So we looked at a few different interesting things. Now this takes us to something a little bit more, and this is where we need to be really thinking about this reduce operation. So for example, let's say you have the numbers, and I'm going to say result is equal to, and I want to output the result at this point. But what am I going to do here? I say numbers.stream, and I do a filter, and given a number, and I'm going to say in this case a number mod 2 is equal to 0. So we got all the even numbers. But I want to know how many even numbers exist in this particular code. So what am I going to do to find the number of even numbers? I'm going to say reduce. I'm going to start with the 0, and I'm going to say a count, and I'm going to say ignore, right? By the way, when you write code, be intentional. How many times have you seen people do X? Come on, raise your hand. Yeah, right? What does X mean? Does anyone know? Oh yeah, nobody knows, right? And you tell, why do you put X? I sometimes play with people. Well, do you want to call it Y? And then do you want to call it W? Maybe a P. Maybe a K is better. The worst offender is L. You don't even know if it's a 1 or a L. And then maybe a Z, right? Why not Z? Maybe A is better, right? I mean, have you ever wondered? I was looking at a piece of code one day. This person had something like a filter, right? And then what you see is nobody's bet. There's a P over here. Maybe there is a K or a L or a Z, right? And then I was thinking, this appears completely random, right? And maybe, just maybe, what if my colleague was abducted and he's being held hostage? But the abductors don't want anyone to know that my colleague was abducted. So they let them write the code. And maybe my colleague is telling the secret location by those names, right? That would be awesome, right? What amazing rescue story would be. You can send the cops and rescue them, and there'll be a story. Lambda expression shaves the programmer, right? That was not the case. And I was able to reach my colleague. And then I was wondering, then I eventually found out what was going on actually. My colleague is writing code, and in the middle of writing code, they do a map, and then they put a parenthesis. Right at that instance, they get a phone call. So like, hello? And when they're talking on the phone, their cat walks on the keyboard. Would you remove a variable name that your cat gives? If I were them, I would grab my cat immediately and say, I'm so happy we get to pair with each other. I love you so much. Now go play, find your mouse, and I'll continue coding. But at least if that's the case, tell me the name of the cat in the comment, right? So we can give attribution to which cat named that variable. If you're not abducted, if you don't have a cat, you have no reason to give names like that. That's the point I'm making. So give names that are intentional. So what are you going to say here? Not a, not a B, not a Z. Ignore. I don't care for it, right? So now you're like, oh, I'm ignoring it. I don't need it. So what am I going to do here? I'm going to simply return count plus 1, and that's a result I'm going to return, and that's going to be 5 elements. Now, of course, you took all this time to write it, but that's kind of boring, right? You don't want to be writing that much code. So what can you do instead? You can instead simply say, over here, I want to simply call a count function. So when I run the code, the result is still the same, so we did a count. Here's a question for you. If I say, what is this? Hey, that's filter, obviously, right? If I show you a map, it's map. But if I ask you, what is count? What's your answer? What's count? In functional programming words. What operation is count? We talked about things like filter, like map. It is. That's what you need to know, right? So what's count? It's a reduce operation. But it is a specialized reduce operation. So your eyes should be seeing these filter, map, and reduce, right? And count is a specialized reduce operation. So count is a reduce. Sum is a reduce. I want to total all the values that are here. So what am I going to say? I'm going to say dot map to int, given a number, I want to return a number, right? So then I say sum those values. That's a total of all the even numbers in the collection. What is sum? It's a reduce operation. What's min? What's max? What's average? Those are all specialized reduce operations. So far, so good. So when you look at the processing of the data, you want to think about these filter, map, reduce, filter, map, reduce, filter, map, reduce, because you are removing data you don't care about. You're transforming data to something you want, and then you're reducing it back to something. So those are the reduce operations, and there are number of specialized reduce operations. And so you can use them based on what you're trying to do. All right, let's take that a little bit further. Let's do some simple transformations of data. So I want to find if all the values satisfy a particular condition. So given this particular value, I'm going to say that the numbers dot stream dot, and what am I interested in? All the values. So that means all match. And given a number, I want to know a number is greater than 0. So, and then I'm going to simply print out the result of that particular operation. So result is equal to like so. So are all the numbers in the collection greater than 0? Is that true? In this particular case, the answer is yes, right? So the result is a true. All the values are greater than 0. What if I say all the values in the collection are greater than 4? What's the result of that? A false, and you exactly see the false. However, what you want to keep in mind is this is going to be a fast exit. So if I say all the values are greater than 0, which values will it process to give you that result? Which numbers will it process to find out all the values are greater than 7? I'm sorry, greater than 0. Every single one of them, right? Is 1 greater, is 2 greater, is 3 greater, is 10 greater, right? If I say all the values are greater than 4, which ones will it process? I heard that voice over there. I heard that one answer. I heard that one answer. 1. Because is 1 greater than 4? No. Why would you want to process 2? Right? If 1 is not greater than 4, does it matter that 2 is not? So it doesn't have to evaluate more values, right? So it's a fast fail. It's like, hey, is every value greater than 4? Oh, the first one, 1 itself failed. We're done. Let's go home. So it'll short circuit it. It is efficient. It's not going to sit there and keep doing the work for no good reason, right? So that's basically if all the values satisfy a condition. If any value satisfy a condition, I want to know if any value is going to meet that expectation. So what do? You say any match. Is anything is greater than 4? Is anything greater than 0? How many elements will it process? 1, right? Because is 1 greater than 0? Yes, it is. I'm done. Because you said any, and I found 1. What if I said 4? How many will it compute in this example? 5, right? 1, 2, 3, 4. Is 4 greater than 4? No. 5? Oh, found 1. And it would compute 5. Not necessarily because it's in that order, right? Until it finds a value. But in this case, if I said 12, what is it going to do? Yeah, 1 and 12, right? So essentially, any is going to, it waits to be affirmative. If it can determine the result and it no longer has to do the work, it's not going to do the work, right? That is called what? Lazy evaluation. And what does lazy mean in English? Efficient, right? You don't want to hire people and they say, you know what? I worked all night. You fire them. I ask them, why do you work all night? You just need to find out what's needed, get it done, and go home. We didn't hire you to work. Anyone here who got hired to work? I hope not, right? What were you hired to do? You got to know this. Deliver the results. If you can deliver the results with less effort, what's that called? Efficiency. I love people who are efficient and lazy. The eager ones are the worst ones. I did all this work last night, and most of what they did is a waste. You have to throw it away. Like, why do you do all this? No need to do it, right? You have to be absolutely lazy. You know, the boss comes to you and says on February the 1st, you have to work on this, and the report is due on April the 15th. So what do you do on February the 1st? You say, thank you, boss, and you go straight to your desk and start working on it, right? No. I heard that. At least one person is honest. No. What do? You start on it on April 14th. Right? Why? Because it's due the next day. It's even better. On February the 1st, the boss says, you're going to work on it. It's due on 15th of April. And you come back to your desk and you say, no problem, boss. And you know you're going to quit on March 1st. Why would you? Why would you spend any effort? Am I being practical? Right? And what is that called? Being smart. Thank you. That's exactly right, being smart. If your boss was smart, you know that those bosses who are very boring, right? The boss says, the final report is due. Oh my gosh, damn it. The final report is due on April 15th, but the intermediate report is due this week. Oh my gosh, I got to do some work now. That's where the bosses become smart after that, right? But the fourth person who quits on March 1st, they're like, aha, I know what you're doing now. We'll do an interim report in the meantime. But that's exactly the point. Laziness means efficiency. So think about this as, how cannot this be cute? If this is cute, nobody is interested in it, right? Do you ever pay for cute code? Cute code is nice to look at, but you don't want to take it home, right? My wife always, we have this conflict all the time. A friend calls and says, we got a new baby, so we go to see the baby. And she's like, oh my gosh, the baby is cute. And I look at the baby and say, baby, 2 years. That's it, right? It's 2 years for human cuteness. What happens after 2 years? Honestly, you tell me, what happens after 2 years? The parent looks at the child and says, you shut up. You're talking too much, right? Well, but I'm cute. I don't care you're cute. You're bothering me right now. Cuteness lasts for 2 years in human life. That's it, right? Cuteness of this code doesn't matter. It's got to perform. If it doesn't perform, who cares it's cute? So cuteness without performance doesn't survive, doesn't sustain. So that's why you need to think about how efficient this is. And is it efficient? Oh yeah. It's not going to do any more work. That's laziness, right? And laziness is baked into it in this particular case. All right, let's do something a little different. This is where we have to think a little bit differently. So let's give it a try. I'm going to say, let's call it process for lack of better words. And I'm going to say in this case, hello, right? So I'm going to say in this case, hello, Eric. Let's just try a few things. I'm going to say in this case, let's say fun, right? So let's take a few of these examples. So what I want to say here is the following. Find the first letter that is repeated in a string. Just think about that for a minute. Find a letter, first letter that is repeated. What's the first letter that's repeated in here? Thank you. What's the first letter that's repeated here? That's right. And what's the first letter that's repeated here? None. Nothing, right? And this is a E, that's an L. So I want to know the first letter that's repeated in each of these. So what are we going to do? Let's say public static. Let's say a process, and you can give a better name for it, a string input. And what I want to do is return something that's a result, right? That's what we want to return in the end. So the question is, what do we do to make this work? Thoughts? How can we find the first letter that is repeated? Take the first letter, H. What was that? Simple problem, right? Map operation. Oh, Java map. Create a map. And for every map, keep a count. H appears once, E appears once, L appears two. But then, but was H before L or E? The map doesn't give you the ordering. Maybe a tree map. What was that? Linked list. Link hash map. So we create a link hash map. And then we deliver an enterprise application for finding the first repeated element. Hey, what's this bill about? $1 million. Would you agree the problem is simple? Yes, no? Would you agree simple problems need what? Simple solution. Who creates complex solutions for simple problems? The government. If you work for the government, great. Job security, right? We need simple problems, simple solutions, right? Let's think about it. So sometimes it's natural It's natural what you're thinking. You're thinking about the imperative. What are the steps I can take to get this done? Think about this as a transformation of data. Think about it as, how would I process this information in a way I can extract the detail out? So if you look at this here, let's talk about hello for a minute, right? The H for hello. So let's go to J shell, just play with it. So I have a string over here. So we'll call this as, var s equal to hello. Let's just write hello here. So that's my string. So what am I going to say? S dot, and I can say index of H. So what's the index of H? It's 0, right? What's the index of E? 1. What's the index of L? So far, so good. Then I say last index of what? H. That's the same, because it is really only one occurrence, right? And then I say, what's the last index of E? 1, same as what it was. What's the last index of L? That's different, isn't it? You see where we're going with this? If the last index and first index are the same, what do you know? Not repeated. If they're not the same, it's repeated, right? So far, so good? Okay, we are making some progress. So let's go back to the code. So I'm going to say input dot split on those words. Give me a stream of that. So we got a stream of all these letters, right? One letter at a time. So import java.util.stream dot. So we got the letters. Great. What should I do now? Dot filter. You have a letter. And what am I going to say? Input dot last index of the letter is greater than input dot index of letter. What will come out of the filter? All the duplicates, all the duplicated letters, right? That's right. I heard you say that. And you said, we want the first one. Or else, what do you want? Nothing. Right? Is the solution simple? Right? So all we need to do is untangle our mind, because not that what you said is wrong, but you write that and you say, looks like a $70 million enterprise solution. Let me think about it again, right? And that's what is the training of the mind. You want to keep asking that question, what can I do to make it simpler? That seems heavyweight. I'm creating a map, but why do I want to create a map? Let's think about simple, simple, simple. Oh, we want a repeated letters. How do you know a letter is repeated? Maybe somebody will tell me, Venkat, there's a simpler way. I want to know if there's a simpler way, right? It is simple as long as nobody finds something simpler, right? That's the beauty of it, right? So you say, how do you know if a letter is repeated? Oh, you can check the index. If the index is the same, it is not repeated. If the index is different, then it's repeated. Good, but I want the first one. And by the way, what will find first do? What was that? It's a reduce. Beautiful. It's a reduce operation. You nailed it. Awesome. I love it. But how is it going to find? Is it going to reduce by evaluating what? In this example, when you send a hello to it, which are the letters it's going to evaluate? H, E, L. What about the O? No, because it is lazy. It's lazy, right? The minute it finds one, I'm done. Hey, what about all these other things in the collection of characters? What do I do with it? Give it to the person who works all night. I'm going to go home to see my family, right? Because I delivered the result. I don't have to be eager to evaluate it, right? That's the key. So it's lazily evaluated. And you can show that to yourself very nicely, if you will. For example, I'm not saying write code like this, by the way, but it can be helpful to understand how this works. So if I go back here, and in this case, I'm going to simply output the letter that we are working with, right? So I can output the letter HELLHEEFUN. Notice the O was never evaluated in the output because it's lazy, right? That's what you're noticing. So you get a feel for how we can start putting these together, right? So these are filter map reduce. That's all we did. We didn't introduce any new concept here. Filter map reduce, filter map reduce, filter map reduce. And as you rightly pointed out, find first is a reduce. And filter, we're just filtering based on the repetition. So when you process data, you want to think about these solutions. But by the way, don't worry about it if you cannot think of it. If you ask me, Venkat, did you wake up one day and naturally you start thinking about this? No. I bang on the keyboard, I kick, I scream, I cry, I walk, I go hike the mountain, and right in the middle of my hiking, I'm like, oh my gosh. And my wife says, what happened? And I say, I found it. She said, what? That I'm stupid. This is easy. Why didn't I not think of it? Now I have to run back and try this example. And sometimes it happens, right? When is the best solution you arrive at often? Come on, be honest. When you're taking a shower. So seriously, if you're running a serious technical company, you need to have more showers. Because that's where solutions are found, right? You're sitting at your desk, I don't get it. And your colleague is like, why don't you go take a shower? Thank you. And then you can even call from the shower these days, right? Hey, why don't you try this? That's why you have pair programming. One person showers, the other person is on the keyboard, right? So the point really is, you want to be away and think about these solutions. How could I do this? And it's okay to get tangled up and then untangle away from the keyboard. And then you're like, oh, I could actually solve this problem differently. Let me try it. And the more different ways you try, your mind begins to untangle over time. And then you are like, and this is great, right? Try a map, try a link map. Great. That's what I thought as a first step as well. And I love it. And immediately the next thought behind it is, yeah, but that seems a little complex. Let me think about something simpler. Until somebody looks at this and says, wait, you don't even have to do this, Venkat. There's something simpler. I'm like, oh, let's try that out. That's the beauty of it. So that's basically an example of how we can find those values. You can find a max and a min based on a criteria similarly. But in a similar way, let's take a slightly different example and play with it. So let's say we have names is equal to list of, let's say, some names that we have with us. So given these names, what they want us to do is the following. Print, comma, separated names in uppercase of length, let's say 4. So what am I going to do? For a var name coming from names, right? Then what do? You say, hey, I have a name, so I want to output name dot to uppercase, right? Uppercase. And I'm printing all the names in uppercase. Great, that's easy. Oh, but only names that are of length equal to 4, right? That's what that says, equal to 4. So when you run it, that's names of 4. Oh, but they wanted a comma separated. Let's put a comma. Hey, but they really wanted them all on the same line, right? So, okay, we'll just remove the ln and do a print. And you run the code, there you go. And then you say, but wait, there's a stupid comma in the end. Anyone who has faced that problem before? How do you feel? What was that? Yes, to create a string builder, he said, right? And he is like, create a string builder. And he is like, is the string builder or string buffer? You fill a timesheet, 2 hours, deciding between string builder and string buffer. Because what if the concurrency issue is there? No, but you don't need concurrency. This is great if you're a consultant. right? Hey, what did you charge 4 hours for? We have to pick, we have to design and pick between string builder and string buffer, right? And then we'll remove it. Don't you feel morally wrong is to put something and delete it? Right? Would you go tell this to mom? Mom, look what I did. I created a string and I removed the comma. And mom says, child, you need to find another job. Right? There's got to be something better in your life to do. Why do you put stuff to remove it? Our moms will never accept this. Right? So, and when you're struggling with this, somebody says, but there's a simpler answer, they say. You're like, really? How did I not know it? What should I do? Don't do this. You're stuck if you do it. You say for int I equal to 0 and I less than names.length, right? Then what do? Then check if it's the last element. If it is not the last element, put a comma. 2 more hours of billing, right? Will that work? Eventually. And you're like, gosh, this is a simple problem. Again, simple problems need simple solutions, right? That's what I always tell myself. When I'm working on a problem, I say, wait. You're just going down the rabbit hole. This cannot be true. Simple problems need simple solutions. I cannot complicate this, right? It's beyond that. So what are we going to do? Names, well, I would put, and we can say names dot stream dot. And what are we going to do here? I'm going to say a filter name dot length is equal to 4 dot map string to uppercase. Okay, great. Then what? Collect joining using a comma, where we bring in the collectors. Very easy, isn't it? Code reads like the problem statement. Given the names, get me the names of length 4, transform them to uppercase, join them with a comma. Question, what's the collect operation again? Reduce. Filter map reduce, filter map reduce, filter map reduce, right? Collect is a special reduce. And the reduce operation is joining the data into one single string. So sometimes we have to find simple solutions. Sometimes we have to find simple APIs that give us simple solution. Maybe there's something there that we don't know yet. We can find that and play with it. When you find a function, when you find a solution you've never ever seen before, what do? You're reading a Java doc or a tutorial, like, whoa, joining. I don't know what joining is. And what do? Interesting. Something called joining. I guarantee you, 2 weeks from now, you won't remember it, right? So what do? You say joining. What's that animal called joining? I've never seen this before. Yeah, note down on a piece of paper, right? You have a running list all the time. Then on that Saturday afternoon, when you're totally bored, don't know what to do, you write a little program and play with joining. And you spend 20 minutes writing code with joining. You will never, ever forget this again. Because it went from I've seen it to I've understood it. And that's how you start remembering things, not by just memorizing things, right? So, oh, I saw this joining, but I'm going to write a little example, play with it. Spend 20 minutes on it. What can I pass to it? What happens if I do this? What happens if I do that? And you start tinkering with it, and then you immerse yourselves into it. And as you're doing that, you're going to have so many questions. I will always tell people, I don't want people who have answers. I want people who have questions. Because when you can ask those questions, you're going to go find more answers when you have questions. If you only have answer, you're done, right? So you want to really go find those questions that come to your mind. So that's basically what joining did. Similarly, you can put this to a list or a set or a map, right? You can do all of that. And you can say toList or toSet or toMap, and you can put the data into a set or a map in the collect. So when you go to the collect, you can say, instead of this, you can say, hey, I don't want to collect it. I want to put it into a list, like so, right? So this says, go ahead and put it into a list. So now you can see all the names in a list. So to list, similarly to set, you can put into a set. Or you can put into a map as well. You can say to map. What am I going to say? Given a name, put the name. Given a name, put the name dot length of that name. Now this is a bit silly because all the names are of length 4, but you can do that, right? So that gives you a map. Or you can say, get me the name char at location 0. So D starts with the D, or G with G, and N with N, Nemo with N. You can create a map on it. So things like that you can do very nicely with it. Then comes along partitioning. So what does partitioning do? You take this one, and if I tell you, only get me the names of length 4, you can do that, right? Easy, filter. But what if I say, give me names, names of length 4 and those that are longer. I want names that are length 4, or less, right? Or less. And those that are longer. You don't want to iterate through it twice, right? You don't want to run through it. Here's everything that's less than 4, and here's everything that's 4 or more. That's kind of boring. So what can you do? You can say here, hey, names dot stream dot collect. Okay, I'm going to collect it. What am I going to collect? Partitioning by. And what am I partitioning by? Given a name dot length is less than or equal to 4, of length 4 or less, right? Less than or equal to 4. So partitioning by of that particular length. So partitioning by that length. So illegal sort of expression. Okay. So this is basically saying I would like to bring in all the, so names.stream, and we are calling a collect function. We are partitioning by given a name, and I want a name of length is less than or equal to 4, and that's the end of the partitioning, that's the end of the collect, that's the end of the print line. That's what we are interested. So the false is Bruce, Darla, Marlin, and Jacques. And true is Dory, Gil, and Nemo. So that partition into 2, right? Those that satisfied and those that didn't. That's your partitioning by. So you can split that into 2 and give it to you. I'll only mention about teeing right now. I won't go into the details right now. But teeing is a concept where you can do 2 transformations and merge them together. Very powerful operation. I think teeing was introduced in Java 16. If you're interested, take a look at that even further. That's great. That brings us to grouping by. So what is grouping by? Grouping by, I want to take these names, but I want to group these names based on the first letter. All the D's, all the G's, all the B's. So grouping by, think of this like a bucket. Imagine you have buckets right here, and the buckets have labels on it. When you take a name, you put that in the bucket with the first letter, right? That's all you're doing, putting it in a bucket. So that's a very simple concept. How do you do it? I won't write this code in imperative style, but I want you to think about the imperative style code for a minute, right? What do you do in imperative style? Create an empty map. Make sense? What is a map? Key is the letter, list of names. So far, so good? And then start looping. What's the first thing you do? Take the first name. Take the letter. Is the letter in the map? It's not. Create a list, first of all. Put the name in the list. Put the list in the map. Take the next one. Is the letter in the map? Oh, there is. Get that list now. Mutate that list with this new element. Anyone wants to do this? Raise your hand if you want to write that code. 2 people. The rest of us know not to do it, right? Why? It's a lot of code, isn't it? But you still have to deliver that code. I mean, they 2 are right? The boss is like, get this work done. What do? Those 2 are going to write it. What about the rest of us? That's why we hire the intern, right? And we tell the intern, do this. And they're like, oh, thank you. This is great. Right? This is what experience is, right? What is experience? You learn to write less code. When you get really experienced, you don't write any code. That's called being an architect, right? No, just kidding. So the point really is, you want to really remove all that burden. So what are we going to do here? We can say in here, output names dot stream dot grouping by collect. That's what we want to do, right? Grouping by, what am I grouping by? Given a name dot star at 0. B, Bruce. D, Dory and Darla. G is Gil. J is Jacques. M is Merlin. N is Nemo. Make sense? So we can start grouping really nicely. But maybe I don't want to group it by the names. I want to know how many letters are in those names. Right? I want to know how many letters are in those names. Sometimes you want to play with these kinds of names, right? You can think about your own, experience, right? I want to find all my friends, and I want to group them and see, how many friends have these kinds of names, what the letters are, things like that you want to find. So in this case, what am I interested? What did we give so far? We said the map is D, contains Dory and Darla, right? And then we said the map contains a G, contains Gil. But what I want instead is D colon 4 comma 5, G colon 4. Am I making sense? I just want the length of the names, right? That's what I really want, isn't it? So we are saying, hey, put this in a bucket. That's what you said, right? Put in a bucket. But wait. You know the bucket now. Don't put the name in the bucket. What should I put in the bucket? The length of the name. And you don't want the name, but you want the length of the name. What function comes to your mind? Not the name, but the length. Transformation. Transform the name to the length. What's the transformation function? Map. So you want to mapping, and what are you mapping? String length. That's what you want to map, right? Mapping, and you're mapping based on the length of the string. Oh, that's more errors. So let me try this again. So you have this value, you got those results. Now you're saying, I want to group based on that, and then mapping, and what do you want to mapping? Mapping, you want to take a name, and you want the length of the name, right? That's what you're trying to do, is to get the length of it. Let's see, collect, apply, grouping by, requires function, super, that's what I tried to give, found function length. All right, let's do this name, and I want to return name.length, which is what I'm trying to provide here, but for some reason it's not happy with me. I'll move on if it doesn't work, but you get the idea on that, right? So anyway, so you're going to perform the mapping operation on this one when you are grouping it. That's what you're saying. So I want the bucket to be name, but I want to put that in mapping. I have to resolve through the syntax, but you get the point. So that's basically the transformation of the data that you're going to perform in this case. So as you can see, you can group and you can perform the mapping operation. You can even do a counting, meaning I want to know how many of my friends are really with that name. So comma, counting, right? So you're saying, I want to count the values. I got one person starting with a B, two with the D, one with the G, and so on, and you're doing a counting, which is what I was trying to do with the mapping operation as well to perform that particular transformation. So you can transform the number of letters, or you can transform the name like that. And similarly, you can do other operations like filtering, and you can provide those kinds of operations. That becomes a very powerful operation. So to summarize what we talked about, you want to think about this transformation of data. I have this collection of data. How am I going to transform it? The general theme is filter, map, reduce, filter, map, reduce. But that reduce can be enormously complex. And as you saw there, you can collect it to a list or a set. You can collect it by partitioning, collect it by grouping. While you're grouping, you can do mapping, or grouping, you can do counting. That becomes a recursive operation. Very, very powerful set of operations, as you can see here. And you can spend an entire week learning about that collectors utility class, extremely powerful. And I encourage you to spend the time. But one of the best ways to learn is not to read it, but to write it. So play with it, create examples, make them work, tear it apart, break it. And while you're doing it, you're like, hey, what if I do this? Try it. And now you're grounding those concepts in your mind. And now the clarity begins to emerge because you see things very differently because you're able to see it at that level. And that's a beautiful journey and very powerful way to learn. Hope that was useful. That's all I have. Thank you.